Hello everyone, my name is Olena, and in this video, or maybe a series of videos, let's see how it goes, I want to build a simple flight tracker simulator. And the end goal is to create a data generator for experiments with Apache Kafka, Apache Flink, OpenSearch and other solutions. So we will see in the future what exactly we are going to build with it. But let me first explain you the idea which I have in mind. So imagine that we have a schedule for the flights for a whole day. At any point of time, and it is for example 8:40 a.m. in the morning for me right now, I can connect to that schedule and see where are the airplanes right now according to that schedule. Are they in the air? And if so, what is the location? Or maybe they're still waiting for the departure, it's later in the day, or maybe they are at their destination already. So we will get the locations for those airplanes on a regular interval, and then we can use that data for further actions. And to help verify that the logic is correct, I also want to add a very simple local UI with a leaflet and a map and other stuff. And once that is done, once we can see that everything works correctly, we'll start streaming the data to Kafka. And once we have it in Kafka, we can process the data with Flink or also bring it to OpenSearch for aggregations and maybe visualizations, also with OpenSearch dashboards. But those are the next steps. Let's start with simple and then evolve the system. To skip a boring task of generating the schedule, I already did that, and I have a list of airports which I decided to use for our flights. Then, based on that, I created a script where we have the information about the airports. We take it from that file. Then there is the aircraft's types. Oh, I do have some repeatable values here. Okay, I need to clean that. But in general, we have some Airbuses, we have some Boeings, we have some other airplanes, which I have no idea about. And then we take the random values for the departure time, for the departure airport, for the destination airport, for the aircraft, generate the flight number, and then create an object with all those values. No magic here. So at the end, we have something like this. For example, I have here some airport, and I don't know which airport it is, but we have the information about the airports, we have the information about aircraft, we have the flight number and the departure time. And then it's pretty long document. I think it's more than 10,000 items here. Yes, in the script I have a parameter. Let me find how many I generated. Oh yeah, I generated last time 16,000. Maybe it is too much. Let's see, maybe the system is not that efficient, but we can think about it a bit later. So we have the schedule. Next step would be to create a function which can calculate the location of the airplane, of the flight in progress or maybe not in progress, and tell us what is the status of the flight, and if it is in progress, then what is the location of that flight. So let's do that. Let's create a new file which I will call run.js, because this will be our main place for all the logic. Of course, we need to process the data for all the flights later, but we will start with a single one so that we can see that our logic kind of works. So let me create a function which I will call scheduleflight. And it is a function, and it will take some kind of a flight object which we will get from the schedule file. And over here, what I want to do are several steps. First of all, to understand where the flight currently is, we need to know what is the time when we are, and again, for me, it's in the morning, around 9 o'clock. And then based on that, we can look at the departure of the flight and the destination, and we can estimate, is it still waiting for departure, or has it arrived, or is it in the air? So first we need to get the current time. Next we need to get the information on the airports where it is flying from and where it is aiming for. Get info on the airports, departure and arrival. Next thing which we need to know for our calculation, because if it hasn't departed yet, that's simple. But if it has departed, it all depends what is the length of the route and if it arrived already. So to calculate that, we need the distance between the airport. Knowing that, we can estimate the position of the, estimate the progress of the flight. We can use some kind of a logic, so to say, to have an indicator if there is like 3 statuses which we can play with, still waiting for departure, in progress and arrived. And then the progress variable will depend on one of those 3 options. And finally, if the flight is not in the air, then give a status. That would be the easiest one if it's not in the air. But if it's in the air, if it's in progress, then estimate the position and return result. If not, estimate the position. And then we will return the result, and we will output that result in, say, let's put it here. We will console log the schedule flights. And over here, I would like to take the first flight. Of course, we need to get the flights from the file. So let's go from the schedule, or we will call it const flights, and it will just require, why don't you see require? Okay, I think it's good. And here we will put the data from the schedule file. And then we will take the first flight from the list, and we will use it for verifying if the logic is correct, because here we will have some kind of return status object. It doesn't exist yet, but no worries, we need to populate all this stuff right now. So the current time is pretty easy. Const current time is equal to new date get time. Then we need to get the information on the airports. That information we have if we take from the schedule. Over here for each flight we have the departure airport code and the arrival. And at the same time we have airports, and in the airports it's a dictionary, so we can find those pretty easily. Oh, I want to go to Barcelona. So yes, let's do that. So it will be const departure airport is equal to, here we need our airports. Wait, yes, we need to add const airports. And we will get airports, and here we will get information from flight, departure airport. Yes, exactly. Arrival airport. Let me check what we have in the schedule. Oh, destination airport. Okay, that goes here. Maybe let me call it also destination airport over here. Then the distance one is a bit tricky, and it might be tricky because I'm not really good at math, and especially when we have to calculate the curve and stuff. So I asked ChatGPT to give us a simple function to calculate the distance between 2 points for a flight. So let me use that function. I also asked it very politely to put a lot of comments into that function, so it will be easier for us. So I'll put the function somewhere here. We can move it later to a helper file or something. And this is it. So calculate the distance. We will provide the information about airports, and it will take the coordinates. And in our airports, we have coordinates property. So we will use that one to get the information on latitude, longitude of the first and the second flight. Then this is the radius of the Earth in meters. Thank you, ChatGPT, for pointing it out. I never knew that information. And then we convert that to radians for some reason, and then we do some more magic stuff. So trust me, I tried to run this kind of a draft of the code before, so it seems to be working. Maybe it's not exactly true. If it's not true and you know why it's not correct and you know how to improve it, please point it in the comments. We can change this logic anytime. So this will be calculate distance, and we need to use that function to calculate the distance between our airports. So let's do that. The const distance equal to calculate distance, and we put then our departure airport and destination airport. Next, we need to estimate the progress of the flight, where it is, but for this we need actually to know when the flight is supposed to be started. So for that, let's also add get flight departure time, and for this we will just do const departure time equal to new date get time, and actually no, we don't need the get time, let's keep it new date. And now for the departure time we will set the hours, and here we can provide the hours and the minutes, but we need to get those, so let's do it like this: hours, minutes. Oh wait, we need to do it with const hours, minutes, and it will be from flight which we have, and then we will put the departure time, and it's always in the format of two numbers, 20, 30, and so on. So we will just split it by the column, not sure how it's called, and then we will get our hours and minutes from that information, and we will use then this data, hours, minutes. What else we have here? So we have seconds and milliseconds. I guess we can skip the rest. And I'm not sure why it's actually complaining. Argument is not assignable to parameter time. I mean, it's JavaScript, right? So let's see if it will convert it automatically to numbers. I mean, yes, you should probably do it explicitly and not really get the strings from the stuff and put it into numbers, because of course you can make some errors there. But let's keep it like this. We can improve it later if we have some time left. Next, we need to estimate the progress of the flight. And what I had in mind is to calculate it by determining how much time has elapsed since the departure time, dividing that by total expected travel time, and then using the ratio to interpret the flight current position between those two coordinates that we have. And if that value will be higher than 1, that means that the flight has arrived. If it's lower than 1, it means, or if it's between 0 and 1, it means it's in progress. And if it's lower than 0, that means it hasn't started yet. So let's do it. So first is the elapsed time, and this is the difference between the current time we are in and the destination time, representing how long the flight has been in the air. So let's do it. Const elapsed time equal to current time minus the destination minus the departure time. Here we need to get that time, get time, because that was a date, yes, over here, and the current time is in the time units, so those are milliseconds. We need to remember that. And the next one is the travel time, const travel time. So the total time it will take the airplane to reach the destination, and that one we can calculate by dividing the distance between those two airports by the speed of the airplane. And for the speed of the airplane, we can take any value for our imaginary system. The airplanes can fly as fast as rockets in our system. I researched a bit this, and the speed of the typical airplane will be 250 meters per second, which is fast enough, but I guess we will increase that value just to have a nicer visual effect later. And because this is the value which I found is in meters by seconds, we need to get the value in milliseconds, we need to multiply this by 1000 just to have the same units across elapsed time and travel time, because elapsed time gives us milliseconds. And finally, we can calculate the progress by dividing the elapsed time by the travel time. And here the progress is the ratio of elapsed time to travel time, representing how far along the flight is in the journey to the destination. And we can have three different options here. So first one, let's imagine that elapsed time turns out to be a negative value because the current time is smaller than the departure time. This happens if the flight hasn't departed yet. So for example, if current time is 7 a.m. and the departure time is 9 a.m., that means that we have 2 hours difference before the flight goes for the journey. So elapsed time will be negative in that case, and the whole progress will be negative, assuming that travel time must always be positive value. So in that case, we can say if the value is negative, then the flight is still waiting for the departure. Actually, let's just add straight away that logic. So if progress less than 0, then we can already return some kind of result. And let's just put the flight number here. And it will be flight number, and status will be not departed. We can add more properties later there. So this is the option number 1. Performance, that looks a bit prettier. Next option would be that the airplane has already landed, and that will happen if the elapsed time is bigger than the travel time. So let's imagine that it is 10 a.m. right now, but the airplane, we know that it started the flight at 8 a.m., which means that elapsed time from 8 till 10 is 2 hours. And at the same time, we also might know that the travel time to reach the destination is just 1 hour, which means that we will divide 2 by 1 and it will be 2, which will be more than 1, so that we can say that the flight has already landed because the ratio of those two values is more than a 1. So that we can also add to our logic. If progress is equal or more than 1, then we assume that the flight has landed. So let me just copy that and we change this to landed, which leaves us with a single value or with a single option. If the progress between 0 and 1, that means that the flight is somewhere in the air, and here we want to calculate its position. We are going to interpolate the position of the airplane based on the information of the departure location, destination location, and also that progress value which we calculated, which will be between 0 and 1. So closer it is to 1, then closer it is to the destination airport, smaller it is, then smaller it is to the departure airport. So and we will have to calculate the latitude and longitude of that position. So let's do it. Current position will be, and here we need to have the latitude value, and the latitude value will be to take the departure coordinate latitude and then to add the small fraction to the latitude towards the destination airport. So we will take departure airport, and then we have the latitude over here, plus, and here we will add the fraction, so destination airport minus the departure airport, and that will be multiplied by the progress. And the same we need to do with the longitude. It will be the departure airport longitude plus destination airport. Oh wait, that's wrong. So that should be latitude and latitude, and the same with longitude. And that, if the math is correct, that should give us information about the current position. I wouldn't be so sure that the math is correct, but we'll check it later on the visual interface to see if it's kind of aligns with our predictions where it should be. And we can now return some kind of an object as a result over here. So let's say it will be it will be the flight number. We can get that information, and then it will be the flight number. We can give the whole flight information. Let's give the whole flight information actually. We will use it later for some stuff. And then it will be status, and here the status is in flight because it's being in the air, and then coordinates. Coordinates, and this one can be let's see, this one can be the current position object. And let's add also the timestamp. Timestamp will help us later to use it for some streaming systems for, I don't know, time windows and so on. And it will be date now. It's kind of will be the same as the current time. Yeah, let's give it together with the date and not just the time. It will be helpful, I think, later. Cool. So this will give us that response. So now if I will run this code, so I will just put the node run.js and let's see how many errors we'll get. Oh, wait, look, it actually didn't give us any errors. I'm surprised. So a status not departed. We took the first flight. Let me scroll up. So it's 4 p.m. and obviously it's on my clock is 9:55. So how about I will put it at 9:40. So, and if you will run right now, it shows us, okay, almost. So the coordinates, none and none. Let's see what error we have. I think I know what is the issue. So the departure airport and destination airport, the airports I have this coordinates property versus the IDE suggested to use directly the location, the latitude and longitude. So I assume it should be like this, but I'm not really, I don't understand why the IDE was so convinced that we don't need the coordinates part. Okay, cool. So let's try again and let's see if that was the only error. Oh yes, look, so the coordinates. So let's see it on the map. So I will need latitude and longitude for Google Maps. So I will also select this one. And it gives us location over Madagascar. Beautiful, never been there. And let's also check. So that was a flight from whatever airport it is. So let me just, can I save this in incognito? Oh no, I cannot. So we remember it was over Madagascar. Now there's plenty of airports. Airport. Okay, so that actually makes sense. So it was somewhere over here. So, and it flies from this airport, and the arrival airport is this one. Airport, and this is, oh wow, that's a pretty long flight, but it actually makes sense. So the flight just started, the departure is 9:40, and I was running the code around like closer to 10, so that means that it would just go a bit that direction. If you run right now, let's do it again. And then now it should be a bit farther away towards the continent. Yeah, I think so. I think it works. We can actually increase the speed. Let me do that. So because we provided this information for the speed of the airplane, and what we can do in our logic to say that the speed is not 250 meters per second, but it is, let's say, 1000. And this technically should give us a closer location to the destination, significantly closer. So now I will put this one over here and this one next to it. So latitude and longitude, and we are indeed moving to the destination, which was somewhere in Europe, if I remember correctly. So it looks correct, but we'll see later in detail so that we can observe those movements with visual interface, whatever we decide for. For now, we can bring it back to 250 and we can now implement the logic to take care of all the airplanes in that document and to calculate which ones are still in the air, which ones landed and which ones is waiting for the departure. So let's add a new simulate flights function. It will be a function, won't take any arguments. And here we would like to go through all the flights in the schedule and then run the function schedule flight for each of those. And then we need to store that information somewhere so that we can update that information and then visualize it. So let's add the at the top a variable where we are going to store our flights. So, or our positions of the aircraft. Aircraft positions, for example, or should we take all the air flight statuses? Or how about we do it flight statuses? And that would be an array. But we are going to repopulate that array all over again, and then I will put it as a let so that we can just drop it and create again and again. And then I will take this value. And then we are going to assign to that array values, process values from each of the flights from the schedule. So we are going to take our schedule, how do we call it? The whole, okay, flights. We're going to take the flights information, then we're going to map it. And here we're going to run a method schedule flight on each of those values. And they're going to run the method schedule flight on each of those schedules. So let's say it's a flight, and then for each flight we will do schedule flight. I know, this one. And the result will be the information about each of the flights which you have. So we can try to console log now the values for the flight statuses, which is a terrible name, I think. And let's run it as it is. Oops, that returns an empty value. Because we never called the simulated flight. So let's do this, and it should give us huge, yes. Because it's 16,000 values there, we got a fraction of that, and the rest is hidden, but we have plenty of flights which are not departed. We have flights which are in the air. So now we need to do this operation because we want to build a streaming system. We need to do it on a regular interval, so let's say every couple of seconds. And for this we can set the interval, and here we will provide the function which we want to run with that interval, and the interval itself, so let's say we can do it like every second. We probably shouldn't do it every second, but to see that it works, we can do it every second. And we need to console log, so to see that it actually works, I will remove this call because we don't need it. We right now will trigger it with set interval. And what I want to console log is, let's say, just we will do the length just to see that actually it's triggered every second. So if we run this file again, then every second we are getting the length, the number of the scheduled or a number of flights which we processed. What I would be actually more interested to see is the number of flights which are right now in progress, omitting those which have landed and which are not yet departed. And that we can do over here. We can filter the flights by its status. So we will say that we want to look at every flight and see that the flight status is equal to, what do we call it? In flight. And this should give us a bit of a different values. Let's also speed it up because then we will see a bit more change in the numbers. Let's say that our airplanes, just like rockets, they fly with a speed of 10,000 meters per second. So, and if we run that, we get 253. I expected a bit more change in those values, but it looks logical. I don't know, probably we need to wait for a bit of dynamic for some airplanes to arrive, or maybe there is a bug somewhere. I think I found the issue. So luckily it's not related to the calculation of the positions of the airplanes, but rather it is about how I schedule the flights. And if you remember, I had this simple way of specifying the departure time, just to have an array of possible options every half an hour in between them. So if we were to wait for half an hour, we would be able to see that we get more flights into the system and that number fluctuates. But because, of course, we are very impatient and we were looking at the second by second change, that was too much or too fast to observe any fluctuation in the numbers. So I made a couple of changes here. First of all, I decided to drop this array, and instead now we have a function which I had to collaborate very quickly with ChatGPT to create, is to get the random time with seconds within a given interval. And here I just gave the whole day for those flights, and that function does some dirty magic. We had to iterate a couple of times with ChatGPT to make it right, but the result is that in our schedule right now we have the departure times, and here we have the hour, the minute, and the seconds. So with this and with quite a number of those flights in the schedule, we will be able to observe the dynamic change way faster. This is, of course, a very brave assumption that the airplanes can not only depart on promised time up to the minute, but also up to the second, which is not truly how reality works, but it's very nice for us to see those changes in the system. So let's keep the seconds there. So now if we run it, and by the way, I had to make a couple of more changes. So yes, in the code for the schedule flight, I took into account the seconds, and now we can operate on that granularity. So let's run this code again, and let's see what changed. So now 125, let's see if it will be going down or up. 126, so there is another flight started and was added to the list. 125 again, so it was the landing 124. So we see that there is kind of dynamic now, so it's not truly a constant value of the flights in the air, but depending on the randomization which we have in the list of the schedules, we have more or less flights at a given moment. Of course, this assumes that our flights having a speed of 10,000 meters per second, which I assume is very fast. So we will change that number for more realistic when we will be maybe sending this data to Apache Kafka to have a bit more realistic representation of what is happening in the air in our imaginary world with a lot of flights. But the next step, which I want to do, because I think it looks like it's working, but it's also difficult to say because I don't know how you working with latitudes and longitudes and all those numbers. I'm not really good at. But what I'm good at is looking at the map and seeing how the flight is moving, and if it's really moving from the departure airport to the destination airport, if the movement makes sense. And then we will be able also to play with those the speed of airplane, maybe the frequency with which we update our stream of data. So all those things. So the next step will be to create a very simple web page with a map and with some markers for the airplanes, and then visualize the constant change of the positions of our airplanes.